Hi, my name is Anthony Ramirez,
Hi, my name is Joey Pei.
and we are part of Fuel Cell Senior Design Project, and our advisor is Professor Wang. Here is our outline. We'll be going over the background of fuel cells, the analysis of current fuel cells, our goals and objective for creating a fuel cell, our timeline, our progress, our manufacturing plan for next quarter, and our current budget. So fuel cell is another form of alternative energy where where hydrogen and oxygen react together in order to create water and a voltage difference. The good thing about the fuel cells are that they create no pollutants, as in CO2, NOx, so on and so forth, and only create water in a feed. And as, go back. And the performance of a fuel cell is a lot higher in power density than other forms of energy. And hydrogen is extremely abundant, so there's no worries of not having enough hydrogen around, and can be generated through renewable energy. And as you can see here, we have a polarization loss graph. In current fuel cells, there are three different ways where there is polarization loss. And polarization loss is basically as the current density of fuel cell increases, the voltage difference, or the cell voltage or cell potential decreases as current density increases. But the three ways of polarization loss are activation polarization, ohmic polarization, and concentration polarization. So we have two different fuel cells here. One without a porous media, which is figure A, and two, figure B, with a porous media. What we are trying to do is create a porous media fuel cell in order to create a more fuel efficient and power generating fuel cell. As you can see on the polarization curve prediction, with and without a porous media. With a porous media, you have more of a cell voltage than without.
Okay, now let me introduce the goal and our objectives. Our goal is divided into two main parts. The first part is that we should apply the nanofoam to the channels region to improve its performance. That's a big difference. Our fuel cell from the traditional fuel cell. And the second goal for us is that our fuel cell should meet the requirements of the Department of Energy 2020 targets. That means our fuel cell should have a 0.8 voltage where they could output a current density of 300 milliamperes per square centimeters. Okay. And the timeline for us in our first quarter, our main work is to achieve this design work, this theoretic work. Our work is mainly on the design of the main components and the simulation on the pressure and the thermal. And we should work our manufacturer plan for the preparation for the next quarter. And in the second quarter, we should manufacture our fuel cell and test its performance and keep improving it till its performance meets our requirements. Okay, next one. Now let me introduce our current progress. The first is that the design of the bipolar plates. Since we decided to make our bipolar plates, we have to choose the design of it. The most difficult part of the design of the bipolar plates is to design its flow field. And in the flow field, we decided to use the parallel configuration. It may be not the most be most easy to manufacture. In fact, to manufacture these channels, we decided to make these two play together and the rail and their conjuncture to make these channels. The cross section of the flow channels is semicircle because we derail them out. And the material of the plates is 304 stainless steel. The diameters of the channels are 3 millimeters. The flow field zone will be heated by a heat panel. The area of the channels counts about 70% of the flow field. Okay, so then the thermal simulation is our work done this quarter. Our simulation's objectives is to make sure that the reactor zone can keep a constant temperature. The requirements for that is the bipolar plate should have a good heat removal capacity to maintain the reactor zone temperature steady. The later conversion heat transfer coefficient we set here is 15 watt per square meters Kelvin, and the coefficient between our plates and our heat panels is set to about 20, and the flow is set at about 60. Okay, and the pressure in the pressure simulation, we should make sure that our porous media won't be deformed under pressure. And the pressure mainly comes from the screw bolts and the flow. The flow will have back pressure in lines. So we should test simulations conditions to make sure our porous metal, that means in other words, co-perform, wouldn't deform under that pressure.
This is our manufacturing plan. We will be focusing mostly on using this template right here, in creating our fuel cell. As you can see, it goes end plate, gasket, bipolar, gasket, membrane, bipolar plate, so on and so forth, up until we finish the stack. One of the important things in manufacturing a fuel cell is preparing the polymer membrane and the electrode layer. You prepare the polymer membrane by using diluted water. And as for the electrode layer, there are many ways in which you can prepare and apply it. We are going to do a screen printing, which is the easiest and cheapest way in order to apply and prepare a fuel cell. Nope. Gaskets are, as you can see in the diagram, gaskets are used heavily. The reasons why the gaskets are used is in order to seal off any leakages that the fuel cell can have. And as for the final product, is the fuel cell is going to have bolts to keep it all together. As for testing, we will be testing it through different periods of time, probably increments of 15, after which the fuel cell is fully heated up, only to ensure that we do not damage the fuel cell even further if there is any damages or misplacement in manufacturing, and as well to eventually see a full fuel cell. As for measuring, we will be using a multimeter, oscilloscope, and other forms of measurement. This is currently our budget of materials, as well as your proposal. We did ask for a little bit more money on your proposal than just the materials, because you never know when either A, something goes wrong with manufacturing, or B, there's some faulty material that we have to replace. So our current budget is $1,990, where most of that money is just coming from your proposal, hoping that we have enough money just in case of any damages.